Assalamu alaikum students. This video is the pre-lab discussion for the practical on 12 October. What are the learning outcomes? What are reducing sugars? What are chemical tests done for reducing sugars? How will you learn this topic? You will use the page 19 to 20 of your book. You will use this video and you will attend the lab session on 12 October to observe the tests. Reducing sugars, what are they? Reducing sugars can give electrons to the reagent so that the reagent becomes reduced and the sugar itself will become oxidized. This is the sugar we have, reducing sugar, and this is a reagent. The sugar can give electron to the reagent. So the sugar becomes oxidized sugar, and the reagent becomes reduced. Reagent is reduced. Let's discuss this in more detail. What does reduction mean? Reduction means gain of electrons. So we have a reducing sugar, and then we have the reagent. The reagent is cupric oxide. The sugar will be oxidized to sugar acid, and the reagent will be reduced to cuprous oxide. In this one, the oxidation state of copper is 2+. And in this one, the oxidation state is 1+. How did cupric become cuprous? This is cuprous. And this is cupric. How did cupric become cuprous? By adding one electron. From where did this electron came? This electron came from the reducing sugar. So if a sugar can cause reduction of cupric oxide into cuprous oxide, then this sugar is called reducing sugar. Which sugars are reducing sugars? All monosaccharides are reducing sugars. Some disaccharides are reducing sugars. Some disaccharides, which ones? Example, lactose, maltose. What about another disaccharide which we all know very commonly, sucrose? Sucrose is non-reducing. You have to remember this. Sucrose is non-reducing. So we have all monosaccharides are reducing sugar. Some disaccharides are reducing, example, lactose, maltose, and sucrose is non-reducing. And then of course, polysaccharides are also non-reducing. Now between the monosaccharide and disaccharide which are reducing, we have to know which one is a more stronger reducing agent. Monosaccharides you have to remember this always, are more, you can say, powerful or stronger reducing agents than reducing disaccharides. So we have a very important sentence here. Monosaccharides are stronger reducing agents than the reducing disaccharides. First of all, what are reducing disaccharides? Disaccharides which can reduce, example, lactose and maltose. Lactose and maltose, because they can reduce the reagent, they are called reducing disaccharide. So we are saying monosaccharides are stronger reducing than lactose and maltose. It is enough for you to remember this sentence. If, mashallah, many of you are very curious and you want to know more, why is it so? We can discuss here. So why is it that the monosaccharides are more powerful reducing agent than disaccharides like lactose and maltose? The monosaccharides, what are, first of all, why sugars are reducing? A sugar is a reducing which has a free active group. What's a free active group? For an aldose, it's an aldehyde group. Aldehyde group in aldose, and ketone group in keto sugar or ketose. So any sugar which has a free active group, that is the aldehyde group or the ketone group, that sugar is a reducing agent. Now all monosaccharide, of course, they are not in a bond. So because monosaccharide is not in a bond, they have a free aldehyde group or a free ketone group. Example for aldose is glucose. In glucose, the carbon one has a free aldehyde group. For ketose, the example is fructose. Fructose has a free ketone group on carbon 2. So because they have a free active group, they are reducing agents, the monosaccharides. Then what about disaccharide? We say they are free, they are less powerful as reducing. For disaccharides, whenever you want to know if it is reducing or not, it depends on the bond. So let's come to reducing disaccharides. Take the example of maltose. In maltose, maltose is a disaccharide of glucose. The bond is glucose alpha 1 to 4 of glucose. So the carbon 1 of this glucose has a glycosidic bond with carbon 4 of this glucose. Now, if you look at this molecule, we have to see if there is a free active group or no. This glucose has the carbon 1 is in a bond. Carbon 1 is the aldehyde group. So carbon 1 of this part of the molecule is not free. In this, the second glucose which is there, the carbon 1 is free because the bond is with carbon 4. So carbon 1 is free. So in this disaccharide, out of 2 glucose units, 1 carbon is free. That is why maltose is a reducing agent. It can do reduction, and it is less powerful than glucose because in glucose we have 1 unit and 1 reducing group. Here we have 2 units of glucose but 1 free active group. Let's take another example, which is a non-reducing disaccharide. Sucrose. What is sucrose made up of? Glucose and fructose. What is the bond? Glucose 1 to 2 of fructose. So the first unit glucose, carbon 1 is in a bond with the carbon 2 of fructose. Where is the aldehyde group? Of the glucose and carbon 1. So aldehyde group is not free, it is in a bond. Now for the fructose, where is the ketone group? On carbon 2. Is the carbon 2 free? No, carbon 2 is in a bond. So both the active groups are in a bond. So that is why sucrose is non-reducing. Let's do the tests. So the first test for reducing sugar is Benedict test. What is the importance of Benedict test? To differentiate between reducing sugars and non-reducing sugars and non-reducing reducing sugars. What's the principle? Reduction. Principle is reduction. We can write the principle very easily. Cupric acid, cupric oxide, cupric oxide plus sugar. If the sugar will be reducing, cupric oxide will be reduced to cuprous oxide, and the sugar will be converted to sugar acid. This cuprous oxide, it is red in color. So we will see red in the observation, and it is an insoluble salt. So it will, very good, it will precipitate. So now what will be the observation? You can tell me easily. If we see a red precipitate, it means this sugar is reducing. If we do not see this red precipitate, this sugar is not reducing. Steps, no need to study the steps, but I'll just tell you, we will take 3 ml of the Benedict reagent, add the unknown sugar, and then heat it for 5 minutes in water bath. Observation and conclusion. If we see after heating in the water bath that we have here a red precipitate, it will be reddish, brownish, orangish. It can be any color, orange to red. If we see this red precipitate, we will say the sugar is reducing sugar. Okay, if on the other hand, if in the observation you do not see any precipitate, so no red precipitate, the sugar is non-reducing. So again, the observation and conclusion. If we see the red precipitate, the sugar is reducing sugar. If we do not see the red precipitate, the sugar is non-reducing sugar. That's the first test, Benedict test. Then we have another test for also in which the principle is reduction. It's called Barfoed's test. In Barfoed's test, what is the importance? We have to know the importance, principle, and observation and conclusion for every test. What's the importance of the Barfoed test? It will differentiate between monosaccharide and reducing disaccharide. Why do we do this test? Very easy to answer. We did the Benedict test. We know the sugar is reducing. Now this sugar is reducing. Do I know if it is a monosaccharide? It can be a monosaccharide, right? Or is it a reducing disaccharide, for example, maltose? Both of these, monosaccharide and reducing disaccharide, will give Benedict positive. But do I know if my unknown sugar is monosaccharide or a reducing disaccharide? No, I do not know. To differentiate between this and this, I will do which test? Barfoed test. What's the principle? Reduction. Cupric oxide plus sugar will give us cuprous oxide plus sugar acid. The steps we said no need to study because we only study importance, principle, and observation and conclusion. observation and conclusion is same as before. If we see the red precipitates, it is a monosaccharide. Example, glucose. If we do not see the red precipitate, there is no red precipitate. So it means the unknown was a reducing disaccharide. This test is also reduction, but it is positive only with powerful reducing agent. Which one is powerful? Monosaccharide. Monosaccharide will give red precipitate, and reducing disaccharide, but because it is not powerful, will not give precipitate. Let's do the difference between monosaccharides and reducing disaccharides. First difference, monosaccharides are stronger reducing agents. Between the two, these are stronger and these are less strong reducing agent. That's the first difference. Second difference, Benedict, actually it's not a difference, it's a similarity. Now we are only comparing and contrasting. Benedict will be positive, and here also Benedict will be positive. Very good. Then Barfoed. Barfoed will be positive here, whereas Barfoed will be negative. What are the examples? Glucose, fructose. What are the examples here? Maltose. Let's analyze different scenarios. So you have some unknown. We have unknown in beaker A. If I do for the unknown and the Benedict is negative, what is my conclusion? Non-reducing. So I have an unknown sugar. I know it's an unknown. I know it's a carbohydrate because I did Molish, which was positive. When I did Benedict, it's negative. So what's my conclusion? Non-reducing. Example, sucrose. I have another unknown in beaker X. I did Benedict, it was positive. Whenever Benedict is positive, I will not stop. I will go and then do another test, which is Barfoed. So when I did Benedict, it was positive. I did another test, which was Barfoed. Barfoed was also positive. If both are positive, my conclusion is monosaccharide. Example, glucose. Another, I have beaker Z. I did Benedict, it was positive. Whenever Benedict is positive, what will I do? Another test, Barfoed. When I did Barfoed, it was negative. So Benedict positive means reducing. Barfoed negative means not strong. So what is reducing but not strong? It's a reducing disaccharide. Example, lactose. Let's repeat this. I have an unknown in beaker A. I did Benedict test. It was negative. So my conclusion is it's non-reducing. And I'll stop here because it's non-reducing. I have another unknown in beaker X. I did Benedict, it was positive. After Benedict is positive, I will not stop. I'll do Barfoed. Barfoed is also positive. So the unknown is monosaccharide. Example, glucose, fructose. I have another beaker unknown Z. I did Benedict, it was positive. When Benedict is positive, I have to do another test, which is Barford. Barford is negative. Benedict is positive means a reducing sugar, and Barford negative means it's not, it's a weak reducing or not strong. So which one is reducing but not strong? That's reducing disaccharide lactose. Thank you. Any questions? Don't hesitate to contact me.